In 1981, 3 engineers founded SMA and became pioneers of the global energy transition. Their vision was to provide renewable energies to people across the globe. Our mission is now more relevant than ever. We want to shape the energy transition with your help. Welcome to Let's Talk Energy. Broadcasting live from the new Solar Academy studio at our SMA headquarters in Kassel, Germany. Learn all about the latest innovations and developments at SMA. Let's get started.
Hello and welcome to another session of Let's Talk Energy at SMA. Today we have the topic of predictive maintenance, and my name is Bernhard Schütz. I'm the head of global services at SMA. Since 2017, when I joined SMA, predictive maintenance was kind of our horizon, but now we're really approaching it. And to talk about the details, I brought with me today our expert, Matthias Gröne. He's specialized in our algorithm for predictive maintenance. Matthias.
Thank you, Bernhard. I'm Matthias Gröne. I have been working at SMA since 2010 and currently act as technical manager. And doing so, I represent SMA's core development team for predictive maintenance.
Thanks, Matthias. And Matthias' experience, I can add to that 20 years experience in the service world. I have been commissioning myself as a young engineer and climbed through the ranks, now contract management, O&M, and finally I ended up with SMA and the global service responsibility. But the expertise you have here, we also will present our expertise for you in the chat at the end of this session, so you have enough time to ask all the questions you have and you might get triggered here during our presentation. First, we have a short questionnaire that we direct to our audience, and the question you're going to be asked is, how many failures, unpredicted failures, did you experience in your job with PV or storage environment as a field tech or as an owner, as a maintenance responsible? There's going to be a short window popping up and asking the questions. Please participate. It gives us a feeling of how stressful these situations are for you. And to continue then, while you are doing that questionnaire, let's go a little bit into details. What are the situations our customer normally face? So we have the market situation. Sorry, that was the wrong one. PV and storage assets are continuously more in competition with traditional power generation assets. Now, the assets and the PV and storage plants are under price pressure, and the grid requirements are not getting easier. While there are several risks for PV and storage plants, the unplanned shutdowns and power interruptions represent one of the biggest ones. That's also with an economical impact. Then we have hidden defects on the equipment that are hard to detect and also hard to react to. Then what is even more disturbing is some OEMs have left the business or are hard to get. Think about the pandemic and travel restrictions, how you want to get the specialist to site. And all this together, unplanned maintenance represent one of the biggest commercial risks for the PV assets. So how does predictive maintenance differ from traditional maintenance? We have here 2 basic options. The preventative maintenance, that is an action that follows a time schedule. Parts get exchanged. It's 100% plannable. It's 0 risk for the asset owner, but you may have to exchange a part before its lifetime is ended. So then you have the other one, corrective maintenance. A failure happens and you have to react to that with a service, with a part. It's 100% risk. You can't foresee it. It could be huge. It could be small. So we in predictive maintenance, we SMA try to define these condition-based actions. That means we are monitoring the condition and we trigger certain action based on a deviation that we observe or component behavior that we observe. And combined with our knowledge and algorithms, that should lead us to a much more slimmer maintenance, less costly. So we have all the building blocks in SMA to develop this algorithm, but also to verificate them that they are correct. They're not just false alarm that trigger any blind action. Then we have a huge installed fleet. SMA has installed and delivered more than 100 gigawatt globally on inverters. We have data from all operating condition and all environment. We have a combined 40-year experience in field service to fix our equipment in the field in over 130 countries in the world. Our target really is to change the ratio between planned and unplanned maintenance using our smart algorithm at the end, making unplanned risk plannable, reduce downtime, and reduce risk for our owners. In order to show you how we do that, that's why we have Matthias invited here to show you in a deep dive what is that we call our algorithms for predictive maintenance. Stay tuned. Thank you.
I would like to give you some technical insight on how SMA approaches predictive maintenance. We did start in the first step with our central inverters, the Sunny Central CP, the Sunny Central and the Sunny Central Up, because they do stand out because of their very high power density and their reliability. They do stand outside and are exposed to harshest conditions in very cold, very warm, or very moist environments. Due to this, they also are the brain and the heart of the power plant. They do see what's happening on the side of the PV panels. They also do see what happens at the battery, in the grid, or inside the inverter. This brings them into an ideal position to act as a key to the power plant's maintenance. So let's have a look then on which issues and which components we can analyze. We do already have a very solid background for fans and power stacks. We can analyze upcoming issues early and can alarm our customers when that's necessary. Next feature set that we have is the isolation resistance of the PV panels. We do have some functionality here that can give us insights on issues that come up on the side of the PV panels. And we also have some background on issues of the AC side, such as over frequency, over voltages, under frequencies, under voltages. If those happen frequently, we can alarm our customers and they can, for example, talk to their electricity company. As some other steps in the future, we also do see that we will focus on components which are exposed to wear and tear, such as the AC and DC switches and the GFDI, so that those components can be replaced when necessary and not necessarily according to plan. We also will focus on obstacles in the airflow of the inverter, which could cause other issues such as frequent overtemperatures, or they could also be a root cause for other faults if they occur. We also want to be able to understand lots of other issues that we might have that we did not see, so that we can in the future improve our algorithms and be able to alarm early. Also, another huge leap that we'll have will be to compare devices within one plant and be able to see which devices do perform well, which do not perform so well, and then also be able to indicate what should be done. Other steps in the future that we see will be to be able to understand and analyze further if there are underperformances and see the root causes and to rectify them. And of course, we will continuously extend and apply our algorithms in the field and do that not only for PV power plants, but also for battery and hybrid plants. To give you an idea on how the algorithms work, we'd like to show you the example of a fan. What we see here is a curve of the fan speeds in the cabinet of the CP inverters. These curves should be overlapping, and we do see here that this clearly is not the case. I can show you here in the middle of the day that the red curve and the turquoise curve, they should be overlapping, but obviously they aren't. The turquoise curve that represents the fan speed of fan 2 is always much lower than fan 1, and we do see here that we have a clocking pattern. So the fan tries to achieve high speeds, but fails to do so and switches off entirely. From the experience of our experts, we do know that this is an indication of a short circuit of the windings of the fan, which results in a complete failure of the fan within weeks. So by replacing this fan, fan 2, early, we gain a couple of weeks of time and avoid underperformance of the plants. But of course, the algorithms alone are just a small piece in the entire chain of the predictive maintenance algorithms. And key is always the customer that is at the end and in the beginning of the entire predictive maintenance chain. After having talked to our customers, we can connect the inverters and the power plants to our backend, for example, by switching on FTP push, or connecting the power plant manager to the plant and activating it so that the data is sent automatically. And then, respecting, of course, all aspects of cybersecurity, we send the data to our SMA backend and store it in a large database. In this large database, we have our predictive maintenance algorithms running that look for anomalies in the plant at all times. And if they happen to detect an anomaly, we can see this in internal monitoring tools, and we can also create service tickets in Salesforce. If that happens, our service technicians see this in their everyday work and can talk to the customer and decide on the next steps, which should be done to rectify the issues. And this is not just an idea that we have, it's a system that we have up and running and are currently applying in a field test. And to elaborate a little bit more on this field test, it's not a very small field test. We're doing this globally with lots of customers and have around 1 gigawatt of inverter power under maintenance in our monitoring. By doing so, our customers can already benefit from the feature set for predictive maintenance that we have right now. And as we gain experience over time, our feature set will improve and grow and just get better. This is the end of the deep dive, and we'll switch over again to Bernhard and continue with the presentation.
Hello, welcome back. Thanks, Matthias, for this excellent deep dive into our algorithms and what predictive maintenance, how we establish that in our systems. The question remains, why should customers choose SMA for predictive maintenance? There are a lot of offers in the market, a lot of companies that claim that can do it. One main differentiation you can see here on the screen. So in the market, you find a lot of companies that offer monitoring and notification services if something fails or deviates. You see some competitors, they offer predictive maintenance based on your data. If you look at SMA, we can provide the complete system from the knowledge of the inverter and how it's designed and built to the sampling of the data, to the monitoring notification piece, and we have the algorithms that we developed ourselves. At the end, we even have our own technicians that go to site and can verify that that's not a false alarm, but it's really a serious issue that needs to be taken care of right away. And by owning the complete chain of events, we can also be much faster in reaction to the customers without having to go over different company boundaries and then inform a lot of people. This opens up the possibilities of a lot of benefits that customers can get out of it. First, it's a significant reduction for unplanned shutdowns. That's, of course, the main purpose of predictive maintenance. With that comes an increase in uptime for your asset, even more important for storage assets. You can opt to plan better, include this in your maintenance planning and maintenance tasks. So you take the stress out of your company. And with that, of course, it goes a lot of more simplified labor and parts planning. Think about just the late 18 months that we have passed through the pandemic and what stress that put on logistical issues and on services to travel to site with that restrictions in place. So here we have a simplification and a relaxation of the whole chain that's coming into action once you have a failure. Look at the costs at the end. It aims to reduce costs on your services, and it makes your OpEx plannable and optimizable. With this, we can create a true win situation for our customers, an end-to-end data chain that comes from the inverter until the action in the field. And this opens up the possibility of automation. As an example, what we can do with predictive maintenance and with the data, that also not just serves our technician, but the customer's technician or anybody out there that works on our equipment, is our virtual support app that we have been launching since last year, and that's basically rolled out in the field. We have a video with us that we will show you that shows the usage of this data, and it's part of the journey to a digital service world that we are already on. So please enjoy the video. Thank you.
Unscheduled breakdowns, repairs, or maintenance work can often lead to costly downtimes. The waiting time for a service technician is usually much longer than the actual troubleshooting time. It is much more efficient to carry out repairs immediately without the need of an additional service technician from the manufacturer. Customers of SMA solar technology are already benefiting from this digital support for repairs with the virtual support app after a service training. Customers first download the app from your device's app store. To start the application, the technician scans the marker on the inverter with a smartphone or tablet. The Visual Support app visualizes information about the components, their positions, and combines the associated documentation, such as circuit diagrams or service information, in one digital platform. Industrial-grade augmented reality technology is provided by Oculovis. If a component is defective, the technician carries out the repair independently using video or step-by-step instructions. A functional test completes the work. If further technical support is required, technicians and SMA experts connect with AR-powered video calls using a smartphone, tablet, or smart glasses. Augmented reality overlays enable the SMA expert to offer precise instructions to the technician on site. Screenshots or video recordings document valuable knowledge and can be transferred to other applications. SMA successfully deploys the virtual and remote support app and inspires its customers worldwide with a sustainable, digital, and customer-oriented service. These innovative solutions save valuable time and costs of on-site operations, minimize downtimes, and thus increase the profitability of PV systems.
With this, we are at the end of our session, and I would like to invite you to our second questionnaire that is going to come up in your window, and this time we're going to ask for your input on what is, in your opinion, the component that is most prone to failure on site. If you have PV or storage asset, which component do you think is the failure most often, unplanned? Matthias, thank you for your participation here. We're going to be available for another half an hour in the web chat. That's going to open up right away. So you have any question, please direct it there. And thank you very much for your time and your attention.
Thank you so much.
Thank you for your attention. We look forward to your questions and comments during the discussion with experts. Just follow the link.